Hello everyone, welcome to the second of Huawei HCIP OpenELR certification course. In this section, we will continue to learning OpenELR cluster architecture. We have learned what cluster is and common cluster deployment tools such as LVS, Nginx, HAProxy, and CableLabs. Next, let's learn Radius, which is an open-source memory data structure storage system, and it's commonly used in the cluster architecture.
Now, let's learn about Radius. As an open-source memory data structure storage system, Radius is designed to combine high performance, flexibility, and reliability, and is widely used in databases, caches, and message middleware fields. Its core competence is centered around 6 key features. The first one, in-memory data structures, or in-memory database. Radius goes beyond traditional key-value storage and provides rich data types, such as strings, hashes, lists, collections, ordered collections, bitmaps, hyperlog algorithms, and geospatial indexes. These structures directly reside in memory. This greatly accelerates data access and processing. And second, programmability. The built-in LUA script engine of Radius allows developers to directly write scripts on the server to perform complex logical operations. It not only improves execution efficiency, but also achieves automaticity, enhancing data processing flexibility and efficiency. In terms of scalability, the Radius cluster uses the automatic data sharding technology to distribute data to multiple nodes, easily cope with the rapid growth of data volume and access traffic, achieve horizontal expansion, and simplify maintenance. And next one, durabilities is an important mechanism for Radius to ensure data security. Radius supports RDB snapshot and AOF log modes to ensure that the data can be recovered even after the power failure or system failure, providing data assurance for ever-changing service scenarios. When it comes to clustering, Radius cluster not only implements efficient data sharding and balancing, but also uses the automatic failover mechanism to ensure high service availability. Even if a single point of failure occurs, the overall service continuity is not affected. Finally, the high availability is enhanced by the Radius Sentinel. This distributed monitoring system can monitor the status of Radius instance in real time. Once the primary node is faulty, the failover process is triggered immediately to seamlessly switch services to the secondary node, ensuring uninterrupted data services. In a word, Radius builds a comprehensive and powerful data storage solution based on the high efficiency and programmability of memory database, flexible scalability design, diversity persistent policies, stable cluster deployment, and high availability, meeting the strict data processing requirements of modern applications. After learning the basic concept of Radius as a high-performance, open-source memory data storage system, we will now dive into one of the core features of Radius, rich and diverse data structures. These data structures are the key to Radius' efficient solution to problems in multiple application scenarios. Next, we will discuss the characteristics and application scenarios of each data structure in detail. First one, strings. As the most basic data type in Radius, it allows you to associate a key with a value, which can be a string, an integer, or even a floating point number. This simple and direct key-value pair design is ideal for strong basic user information, counters, or simple configuration information. Second one, list. The list data structure is an ordered string list, and new elements can be added to the hand or tail of the list. This structure is ideal for implementing message queuing, recording user browsing history, or simply queuing tasks. And for sets, a set provides a way to store non-repetitive elements, ensuring the uniqueness of all members. This is useful when deduplication operations are required, attention lists and tagging systems are implemented. Next one, hash tables. A hash type is mapping table between fields and values. It is suitable for storing objects, such as user information and commodity information. It allows you to organize data in a more structured way, improving query efficiency. Stored sets. Ordered sets add the storing function based on the set. Each element is associated with a score, and Radius automatically stores the elements based on the score. This is very useful for ranking, weighted search result sorting, and other scenarios. Next one, streams. It is a special data structure designed for message queues and supports multicast, persistent message, and consumer group management. It provides a solid foundation for high-throughput messaging and complex event processing. And next one, geospatial indexes. Geospatial indexing allows you to store data with geographical location information and perform operations such as searching for nearby locations and calculating the distance between 2 points. Geospatial indexing is applicable to scenarios such as map applications and location services. Bitmaps use binary bits 0 and 1 to efficiently store Boolean data. Bitmaps are applicable to scenarios such as user online status and user feature marks, greatly saving storage space. And then bit fields. Bit fields allows you to perform operations on multiple consecutive bits on a string, such as setting, opting, or updating multiple bits at the same time. It is useful when you need to fine-grain control bit-level data. And final one, hyperlog. A probability data structure used for cardinality statistics, that is, estimating the number of non-repeated elements in a set. While occupying a small memory space, it can estimate the cardinality of large-scale datasets quickly and accurately, and is applicable to scenarios such as daily active user statistic. The data structures of Redis cover basic key-value pairs to advanced geospatial indexes, each optimized for special scenarios, making Redis a powerful and widely applicable data solution. Understanding and skillful use these data structures is the key to exploit the potential of Redis and improve application performance. Now, let's dig into how Redis ensures data security and durability through its two main data persistent policies, RDP and AOF. First, for Redis database RDP persistence. The RDP uses snapshots. At a present interval, the RDP generates a complete data snapshot for the data set in the current Redis memory and writes a snapshot to a .rdp file on a disk. This process is non-blocking, which means that the Redis can continue to process requests from clients during data backup. The RDP has the advantages of fast recovery and small file size. It is suitable for periodic data backup and disaster recovery. However, it is important to note that if a failure occurs between two snapshots, data since the last snapshot will be lost. Another one is append-only file AOF persistence. Different from the RDP, the AOF uses the log recording mode. It appends all write commands, including write, update, and delete commands executed by the Redis server to the AOF file. It means that AOF records all changes since the creation of the database, providing a higher level of data integrity assurance. AOF provides three different think policies: always, everysec, and no, to balance data security and performance. During data restoration, Redis replaces the commands in the AOF file to rebuild the data status. Although AOF provides a better guarantee of data durability, a file can grow very large over time, requiring a periodic AOF rewritten to compress the file size. So to achieve the best balance between data security and performance, Redis allows you to enable RDP and AOF persistence at the same time. In this way, the RDP can be used as a periodic data backup point to provide quick recovery, and the AOF ensures fine-grained data recovery. The combination of RDP and AOF can build an efficient and secure data storage solution. With fine-grained configuration, developers can adjust persistent policy based on service requirements to achieve optimal data security and performance. Okay, now let's continue to understand the implement process of RDP and AOF to core data persistent mechanism of Redis. First, let's see the implementation procedure of RDP. First step, Redis server trigger point. When the preset time point or the data change reaches a specified threshold, the Redis server realizes that snapshot backup needs to be performed on the data in the memory. And then, fork operation generate child process to prevent the backup process from interfering with normal read and write operations. operations, the Radius server uses the fork function provided by the operating system to create a copy of itself. That is a child process. This process is done almost instantaneously and has no impact on the main process's services. And then the child process executes a snapshot. The newly born child process starts to dump all data status in the present process to a temporary RDB file. This process is offline, which means it does not interfere with the normal data processing of Radius. And finally, replace the old snapshot file. After the snapshot is complete, the child process replaces the old backup file with the newly generated RDB file. This lastest RDB file can be used to quickly recover data when the main process experiences an unaccepted stop. And next, let's see the implementation procedure of AOF. First, client initiated write operation. When a Radius client requests to write, update, or delete data, the command first reaches the Radius server. And then command synchronize record. After receiving the write command, the Radius server not only performs the operation in the memory, but also appends the command to the AOF buffer. This process ensures that all change actions are recorded in real time. And then, write command persistence based on a configuration sync policy, for example, per second or after its write operation. The content in the AOF buffer is periodically or in real time synchronized to the AOF file on the hard disk. This step ensures that most of the data changes are retained even if the system crashes. And final step, AOF file rewriting. Over time, AOF file may become large due to frequent write operations. RDS provides a rewrite mechanism to create a new AOF file that contains only the minimum command set requirement from rebuilding the current dataset at the appropriate time, optimizing storage space and subsequent data recovery efficiency. So in this preceding process, the RDB provides quick data recovery in the form of periodic snapshots, while the AOF ensures that every data changes is faithfully recorded in the form of appended logs. The combination of two ensures high availability and durability of Radius data. And next, let's talk about common Radius commands. These commands are critical for routine data addition, deletion, query, modification, and maintenance, ensuring efficiency operations and management of data items in the Radius database. First group is data addition and query. First, the operation of adding a key-value pair is very direct. Run the setKeyValue command. Here, the key is unique identifier you set for the data item, and the value is the data content that you want to store associatedly. For example, executing set user 123 Alice will create an entry in the database with the key user123 and the value Alice. To check whether a key exists, the command exists key comes in handily. It will return 1 for existence and 0 for non-existence, which is very quick. To query the value corresponding to the key, simply use getKey. For example, after the getUser123 command is executed, the screen displays Alice. That is the previously set value. And the second group is data browsing and deletion. To get an overview of all keys in the database, the keys with stars command displays a list of all keys. However, it is important to use this command with caution in large database, as it can consume more resources. Also, you can delete a specific key by running the del key command. For example, you can run the delete del user123 command to remove the created user123 key value pair. And the third group, data validity period management. To set a lifetime of the key, you can use the expire key command followed by the valid time in seconds. This applies to data store requirements that are temporary in nature. And the TTL key, on the other hand, helps the user to see the remaining validity time of the key. And the fourth group is inter-database operation and management. In the multi-database environment, the need to move keys to different databases can be achieved by using move key database number, where database number, for example, 0 through 15, specifies the number of the target database. In addition, you can easily switch the current database by using select and database number. By default, we are in database 0. And final group is about database maintenance. To know the number of keys in the current database, we can run dbsize command. If you need to clear all key value pairs in the current database, one full shell db command is enough. To completely clean up all the database contents, you need to run the full shell command with caution, as this will irreversibly delete all the data on the Redis server. Okay, these are some common Redis commands, which form the basic for routine data management and operations. Mastering these commands will greatly improve your work efficiency and data control capabilities in the Redis environment. And next, let's deepen our understanding and mastering these Redis commands through the hands-on demonstration.
This section describes the Redis database and its rich data types, and also the data persistent modes and common operations. Next, we will install the Redis database in the hands-on environment and then demonstrate its common operations.